All right, got the trick was to put it in a vise just to hold it upright, and then a couple taps with a hammer got it right off. I just couldn't hold it still enough myself. All right, so now that I got the liner off, I want to highlight a couple features of it. So first is replaceable, but second, you can see this relief groove in the back end. That goes on the discharge side. And the way this are cavitation suppression technology. That's because LPG pumps like this one have a multi-phase mixture coming in. There's a mixture of liquid and vapor coming into the pump. And why does that matter? Well, vapor implodes. So the gas bubbles implode when they get to the pressure side, and it creates all kinds of destructive shock waves. And what this cavitation suppression does is it makes those vapor bubbles smaller before implosion. So you can see the flow comes out here through these holes that are tapped there, almost like jets, breaking apart those bubbles, making it so the pump can operate without being destroyed. So we're going to go through now and just look at the various components. I'll show you what to look for with inspect. So the bearings, again, if you tear a pump like this, we probably wouldn't have you reuse the bearings. They're relatively low cost. We recommend replacing, but you are looking to see if the bearings spin freely, if they're lubricated. The grease in the bearing tells a big story. Is it burnt? Is it washed out? Is it full of debris? Is it clean? You know, the story of the grease condition on a maintenance pump tells a lot about it. Just popping off the seal face here. So that's the bearing. When you're looking at the mechanical seal, this one's a good example. I don't know if you'll be able to see it. The seal face on the carbon's chipped. Now this is a trainer pump, that's not surprising. But on your operating pump, any chip on the seal face would yield a leak path. And so you're looking at my seal face, you're looking at the O-ring. What condition are these in? Is there evidence of chatter or burn on either the rotating or the stationary seal face? So yeah, some pumps have cartridge seals. This particular pump has a component style seal where the seal components are installed separately. And then another thing you look at is the discs. We're looking for uniform wear. If wear's only on one part of the disc over the other, you could have a balancing issue. If wear is from you expect wear from the rotor, because again, this makes mechanical contact with the rotor at times, certainly the vanes. But there's other thing, is there debris, sand, and other junk in it that would cause wear. And I don't know if it's loose enough for me to, oh, it is. The other thing that we can inspect is the valve area. So I'm taking this valve apart here. This is the internal bypass valve. And what we're going to inspect on this is the plug itself. So you're going to want to look at the seating face on the plug, and is that seating face smooth and make good contact in here. If it doesn't, then what's going to happen is your valve will be propped open and you'll internally bypass when you don't want to, and that lowers the flow capacity of your pump. So again, what I've just done here, I wouldn't consider this to be a wear part or a maintenance part, but a troubleshooting element. So if you're not quite getting the flow you want, check the condition of your bypass. So now that I'm ready for reassembly, make sure my liner goes in the right way. This goes, the cavitation suppression goes in the discharge, and there is marked outlet and inlet on the casting itself, but you always know the inlet from the side that the RV is on, and there's a little tab inside the cylinder here you'll match with that liner groove. And this went in this came out kind of tough, so maybe it's going to go. All right, there we go. It went in easier than it came out. So now this is where we pick a right hand or left hand pump. So here's my rotor. A right hand pump, you'd have it with from the inboard side, the inlet's on the right. A left hand pump, the inlet's on the left. It doesn't matter for the pump, it all matters on how you want to drive it. We'll build a right hand pump. I will say most of the pumps that we ship are right hand pumps, but that's not to say that they can't be left hand pumps. So at this point, the disc goes on first. Our IOM manual tells you where to put this flow, the pressure balancing groove. The flat side always goes at the rotor. So I believe for this model, it goes in kind of the lower diagonal position here towards the inlet. Next, we're going to stick the carbon seal face with its O-ring Now again, this is a seal face, so you want to be careful with it. I'm not being very careful in this video though. And then it mates with the jacket. Now you'll see there's a tang on the jacket that fits a mating groove on my rotor. So I usually try to put the rotor at the 12 o'clock position, so that way my jacket can just fit right there. And you know it's locked in when I rotate it there. So my seal face can get slid in there. So now I'm ready for my head O-ring. That just fits in the gap between my disc and the casing. Now I'm ready for my head seal assembly. You'll notice on the stationary seat there's a tang here. That pin fits in one of these grooves. It doesn't matter which one. So I'll press fit that down. See the tang fit there? So now my head is ready to go on. There's a weep hole at the bottom here. So that weep hole goes down, because again, it's a nice drain port. It drains any fluid between the seal and the bearing. So that slides on like so. And then now I can put a couple fasteners in here and kind of hold it in place. There's one, I'll do one on the other end. And one thing I had mentioned before, but I'll say it again, is what we're doing here is switching out the low-cost elements. The vanes, bearings, seals, O-rings are the low-cost elements of the pump. I'm reusing the heads, the casing, the liner, the discs. Everything else is getting reused. The expensive elements of the pump are used. The maintenance wear parts are the low-cost elements. And you saw what I did just there while I was talking. I pressed the bearing in. How did I do that? Because the bearing is a slip-fit design. That's the benefit of that slip-fit design. So now that I got the inboard side kind of roughly assembled, we'll flip it around. Now that's when I put my vanes in. So my vane has two slots. Let's talk about the vane design real quick. These vanes have a tip, a back end with a strike plate, and two slots. The slots always go in the direction of rotation. So if this is my inlet to my outlet, I want my vanes to come this way. And the primary reason is they equalize the back of the vane to discharge pressure. So if I put my vane here, get a little screwdriver device to point, you'll see there's a chamber between the rotor and the vane. With my slots pointed in the right direction, that chamber is equalized to discharge pressure. And why is that meaningful? Well, if I got a 100 psi pump, and let's just for math's sake, because I'm not good at math, we got 1 square inch. Let's just say the back of that vane here is 1 square inch of area in 100 psi. So what's 100 times 1? 100 pounds per square inch times 1 square inch. It's 100. 100 times 1 is 1. So it's like 100 pounds pushing on the back of my vane if I have my vane oriented correctly. And why does that matter? I want my vane pressed up against the inner side of the liner to get maximum flow rate. And so with our pumps, actually, the higher the pressure that you have, the better flow capacity. So now I'm on the outboard side. I'm going to do the same thing, put my disc on with my equalizing port back to inlet, put my O-ring in. I have my my rotating seal face lined up the tang with the corresponding groove on the rotor. Of course, I put my seal face in backwards. Now again, for this training video, I'm going kind of fast. I would be more careful with the seal face so as not to scratch it. Now I'm ready for my head. I already put my stationary seat on. So at this point I can press this on and put a fastener in. Now what you're going to notice is for the second side, you're going to need to use some thumb power because we are fighting up against the spring on the seal faces. So those seal jackets that hold the kind of contain that rotating face. I have a spring inside, and when I'm sandwiching this head on, I'm fighting that spring. So use some thumb power. But what do you notice about what I'm doing? It's not difficult or precise. It's something that anybody could do with common tools you got in the back of your truck. It's changing out the low cost elements of the pump, and in doing so, and again, this changing out parts is not frequent. Could be every 3 years, could be every year, it just depends. We recommend an offline inspection after the first year and then kind of reset the clock after that, depending on your application. But yeah, just switching out the low cost elements. So now we're going to put the outboard lock nut and lock washer on. All right. Now at this point, I think it's easiest to stick a coupling on. What we're going to do now is center the rotor, and sticking a coupling like this on allows you to spin the rotor a lot easier. And maybe you're better than me. My grip isn't strong to do it without a coupling. So now with a coupling, see, I can turn it that much easier. So what I'm going to do is I'll back this off so it's really loose, and I'm going to tighten this one. So you can take a spanner wrench, you can take a screwdriver, or you can buy one of these Blackmer lock nut tools, and I am going to tighten my lock nut until I feel contact. So I'm going to be turning it, and I'm feeling contact, starting to feel contact. So, and I'm going to call that my 0 point. So I've tightened this into where it's drawn my rotor right to my disc and zeroed it out. Now our manual has, I think it's 2 tang widths. Well, it will tell you in the manual, you loosen that out to 0 to get the right clearance. So I'm going to take my nut that's at 0, and I'm going to loosen it by 1, 2 tang widths, and then find out wherever so here's my my closest tang, and I'll drive this pin, I'll drive that tang into that slot to lock it in place. And now that one's tight, I'm going to come to this other side that I have loosened up, and I'll tighten this up. And with my first one set at the right clearance, I can tighten this one up all the way, and then I know that I have my rotor centered. It's not making contact with either of my discs. There's no metallic parts are in contact with each other. That makes this a very low wear pump, unlike like a Smith gear pump, for example, which has all kinds of metal on metal contact and wear. And unlike other vane pumps, which don't use lock nuts. So the inclusion of these lock nuts that we're doing, and you can't see this in the video, but this is turning like butter. I mean, there is no grinding. The rotor's perfectly centered within my housing, really easy. So again, now that I have that tight, I'll drive in that hang, put the rest of my head bolts on, put my bearing covers on. Now real quick before we end the video, we'll talk about the bearing covers. You have a grease fitting and a grease relief. During the normal online maintenance, when you're greasing the pump, make sure to take this grease relief fitting off, OFF off, while you're doing greasing, because otherwise you can overfill and cause grease to get shoved through your mechanical seals. But yeah, put the bearing covers on, grease up the pump, and you're good to go. And that's how you take apart a Blackmer 1.5 inch, 1.25 inch pump, inspect it, put it back together again.